Hi everyone, this is S. Venkatesh. I'm from CSCT and today we're going to discuss a binomial distribution in probability and statistics. Let's get into the topic. Binomial distribution. A binomial distribution is defined as the probability of a success or failure outcome in an experiment that is repeated multiple times. For example, in a cross experiment, heads or tails, and taking a test could have two possible outcomes, either it is a pass or fail. In the binomial formula, the number of times the experiment runs is denoted by n. The probability of one specific outcome is denoted by p. And for example, in an experiment, to know the probability of getting a 5 on a die roll, if you were to roll a dice 10 times, the probability of rolling a 1 on any throw is 1 by 6. Roll 10 times and you have a binomial distribution of n equals to 10 and p equals to 1 by 6. So there can be two possible success or failure. Success equals to the roll is 5 on a die. Failure equals to if the roll on die is other than 5. And the next, the binomial distribution formula is b of x comma n comma p ncx into px sorry ncx into p power x into 1 minus p whole power 1 minus p power n minus x, where b equals to defined as a binomial probability and x equals to it is the total number of successes, either pass or fail, x or tails, etc. And P indicates that the probability of success on an individual trail, and N indicates and defines the number of trails. The note is that the above mentioned binomial formula can also be written as N6 equals to N factorial by X factorial into N minus X factorial. And visualization of a binomial distribution. Considering a trail of an independent binomial distribution, success in an independent is trails is defined by probability P in binomial distribution with parameters n and p. For instance, in an experiment of tossing a pair coin, the number of hits in 20 tosses of a coin as a binomial distribution with parameters n equals to 20 and p equals to 50%. The expected value of the binary distribution is defined as follows: n into p. The standard error of the binomial distribution is defined as n into p into 1 minus p into whole power 1 by 2. And the binomial distribution, by considering an example of the binomial distribution in an experiment of tossing a failed coin 10 times, then the probability of getting exactly 6 hits can be calculated as b of x comma n comma p equals to ncx into p power x into 1 minus p whole power n minus x. For example, the number of trials n indicates equals to 10. A successing of tossing a head equals to 0.5. And in this case, the probability can be 1 by 2. So q equals to 1 by 1 minus p. The success indicates p. So the unsuccess indicates q. So q equals to 1 minus p equals to 0.5 and x equals to 6. A solution for the example is p of x equals to 6 equals to 10cx into 0.5 or power 6 into 0.5 or power 4. Sorry, power 4 power 6 into 0.5 power 4. And the value can be 0.205078.25. And derivation of the binomial distribution. The outcomes of the binomial distributions are usually depicted as success and failure. The usual notations which are used to denote such notations are P equals to probability of success and Q equals to probability of failure, which is equals to 1 minus Q. Therefore, P plus Q equals to 1. In a Bernoulli trail, each repetition of an experiment involves only two outcomes, either independent or repeated. Independent. In these, the result of one trail does not affect the result of another trail. In the case of repeated, in this, the conditions remain the same in each trail. It states that P and Q remain constant across trails. And sorry. Hmm. In a binomial distribution, the probabilities of interest are those of receiving a certain number of success equals to In n independent trails, each having only two possible outcomes, the same probability p of success. Following defined is the number of different ways which shows n distinct things may be arranged in orders. And next, free throw binomial distribution. Consider a scenario to find the best throw shooter on our high school basketball team. To find a season free throw percentage, free throw binomial distribution is put into the use. For this, consider an example of graphing binomial distribution. Considering a variable p that will represent the free throw percentage of your best free throw shooter. If the accuracy of this shooting throw is 90%, then p equals to 0.9 and p represents the probability of a success. To find the probability, the athlete will make 3 out of 10 shots of his free throw percentage is 90%. Using the binomial formula x b of x comma n comma p equals to ncx into p power x into 1 minus p power n minus x. So this is the binomial